This is Doug Edline, Managing Editor of HPC Wire, and welcome to Executive Debrief, where we interview industry leaders that are shaping the future of HPC. Today, I'm honored to have Matthew Shaxted, CEO of ParallelWorks, a company that has a stated goal of democratizing HPC and AI by offering workflow technologies for R&D practitioners that use diverse computing environments. So we're going to dig into that today and learn a lot more about it. And welcome, Matt.
Thanks, Doug. Happy to be here.
Yeah, so I assume many people in our audience have some experience with HPC clusters.
I would
A
think so.
collection, a collection of servers that can be used together to solve large problems is the way I like to describe them in very simple terms. What often gets lost in the top line hardware specification for clusters, usually, either on-prem or in the cloud, actually, is the software that glues everything together that actually makes them usable. And this is the real where the rubber meets the road for the end user. In particular, I like to learn about software solutions that don't force users to have to become system administrators. And I'm sure you know all about that based on your tool. And that is, to me, a key thing in HPC is to keep people focused on their application, on their research, on their discovery, and not have them get down into the engine room of the cluster and do things to make things work. So with that little introduction, the one question I had, and first is, can you talk a little bit about your company and products, and where did ParallelWorks start? And
Sure.
how do you see yourself in the HPC AI market?
Yeah, and your point about getting in the engine room, I say a similar analogy where we don't necessarily want all R&D practitioners to become the plumbers, right? Other people can do the plumbing. So that's
Yep.
that's actually kind of how I see ourselves. we Our company started actually almost about 10 years ago now. We've been focused on building this piece of software that is designed to do what you said, democratize HPC, move people out of kind of a traditional terminal to access these systems and make them more productive for end users. So 2015, my partner, he was at Argonne National Lab at the time, principal investigator on a workflow technology designed to help take computing workloads that run maybe on a desktop and scale them up to the big iron leadership computing machines that exist across the country. And I was, a lowly engineer running simulations that wanted to scale up my runs, and we kind of started working together and reached a conclusion. And I remember it was the first time I ran on a large Cray machine, 20,000 cores, and got more work computing simulations done than I've done in my entire life. And I said, you know what, maybe there's a market for this in industry. And that's kind of what started the journey. Mid 2015, took about 6 months and built a front-end interface, web-based front-end interface on top of this workflow orchestration software. At the time it was called Swift, but it's been replaced with other open source Python-based products. And we started going after opportunities, and that was 10 years ago, and now we're about a 25 person company, still fairly small. Run it as a organically grown business essentially, and have really gotten in some larger engagements that are seeing what we do and kind of want to do that within their organizations. So we've been a traditional HPC company since our inception. When I say traditional, it's running the big iron machines and the building size computers in commercial organizations. It's operating clusters, HPC sysadmins. Maybe about 4 years ago, we started noticing a shift, though, of the work that end users were doing on our platform were starting to evolve into more machine learning and AI model development and training, initially with object detection and inference and replacing physics-based codes with prediction models. And now, especially with LLMs and everything, we've seen a lot of that the user base uh, running GPU clusters for bridging the gap between running a single GPU single node to multi GPU multi GPU multi node uh, training jobs. So that's been kind of interesting watching that progression.
I know your main product is called Activate, and I assume it's the kind of thing that works on-prem for on-prem systems and in the cloud and maybe in between, to give you a consistent view of the workflow that you're trying to do. Um, and you mentioned AI and HPC. So with your tool, does it really matter what the user's trying to do? Is it developed enough so that whatever the user sits down to do, whether it be GPUs number crunching or GPU AI or just CPU stuff, does it? So how does it you know play out for the user in that respect?
Yeah, I mean, we're constantly building new capability to accommodate, I'd say, more diverse user bases. And one thing I've noticed is that over the years, when you go into different communities that do computing, and I was at the HPC Wall Street and AI Wall Street event last week, and before that, I was on a naval base in North Charleston. Communities have different pieces of software to schedule jobs on the computing resources they have, right? And it really does kind of vary by community. A lot of the AI space is moving to microservice and Kubernetes workloads, and they need to be able to orchestrate tasks on that. So our system aims to make the actual scheduler, we interact with the scheduler layer of these systems and kind of abstract that away for the end users. So when you want to get application portability between, maybe traditional HPC, Slurm, or PBS cluster systems to more and more like microservice Kubernetes systems, we're kind of a layer that can exist to remove the differences between those. So to your beginning point, the end users coming in that are building a workload for whatever it may be, an ML training job, a traditional physics-based, weather forecast model, that the difference between those sites kind of doesn't really matter. We make them all look and feel the same. Our current capability right now, we do that by trying to unify the scheduler layer, which is the piece of software that kind of makes the resources available and fair use policies for those. We abstract that layer away using Slurm at the moment, primarily. And when we run in cloud environments, AWS, Google, Azure, Oracle, we're working on. We run on OpenStack for on-prem clouds, virtualized clouds. We unify that all those diverse interfaces with Slurm. So when you stand up one of these systems through our platform, you're actually just talking to elastic Slurm clusters. And when I say elastic, it means it scales up and down compute nodes as the scheduler needs them. And that's what makes it easy to go between on-prem sites that are typically running some type of scheduler like that. And there's many others, LSF and PBS and Moab Torque, et cetera. And so the gap between then moving into these other diverse systems becomes lower because it's something that people are already familiar with. We are having to accommodate new schedulers all the time. We're working on a Kubernetes integration now, specifically for people running, more operational AI workloads, things like that. The HPC Wall Street event talked a lot about IBM's Symphony product, which is a low latency task scheduler for like high volume tasks. In that space, we should be working on those. So kind of varies all the time, and we just try to bring them all together into one place.
I know your main product is called Activate, and I assume it's the kind of thing that works on-prem for on-prem systems and in the cloud and maybe in between, to give you a consistent view of the workflow that you're trying to do. And you mentioned AI and HPC. So with your tool, does it really matter what the user's trying to do? Is it developed enough so that whatever the user sits down to do, whether it be GPUs number crunching or GPU AI or just CPU stuff, does it? So how does it play out for the user in that respect?
Yeah, I mean, we're constantly building new capability to accommodate, I'd say, more diverse user bases. And one thing I've noticed is that over the years, when you go into different communities that do computing, and I was at the HPC Wall Street and AI Wall Street event last week, and before that, I was on a naval base in North Charleston. Communities have different pieces of software to schedule jobs on the computing resources they have, right? And it really does kind of vary by community. A lot of the AI space is moving to microservice and Kubernetes workloads, and they need to be able to orchestrate tasks on that. So our system aims to make the actual scheduler. We interact with the scheduler layer of these systems and kind of abstract that away for the end users. So when you want to get application portability between maybe traditional HPC, Slurm, or PBS cluster systems to more and more like microservice Kubernetes systems, we're kind of a layer that can exist to remove the differences between those. So to your beginning point, the end users coming in that are building a workload for whatever it may be, an ML training job, a traditional physics based, weather forecast model, that the difference between those sites kind of doesn't really matter. We make them all look and feel the same. Our current capability right now, we do that by trying to unify the scheduler layer, which is the piece of software that kind of makes the resources available and fair use policies for those. We abstract that layer away using Slurm at the moment, primarily. And when we run in cloud environments, AWS, Google, Azure, Oracle, we're working on. We run on OpenStack for on-prem clouds, virtualized clouds. We unify that entire all those diverse interfaces with Slurm. So when you stand up one of these systems through our platform, you're actually just talking to Elastic Slurm clusters. And when I say Elastic, it means it scales up and down compute nodes as the scheduler needs them. And that's what makes it easy to go between on-prem sites that are typically running some type of scheduler like that. And there's many others, LSF and PBS and LoWeb et cetera. And so the gap between then moving into these other diverse systems becomes lower because it's something that people are already familiar with. We are having to accommodate new schedulers all the time. We're working on a Kubernetes integration now, specifically for people running, more operational AI workloads, things like that. The HPC Wall Street event talked a lot about IBM's Symphony product, which is a low latency task scheduler for like high volume tasks. In that space, we should be working on those. So kind of varies all the time, and we just try to bring them all together into one place.
It gives me a little bit of insight into the next question I was going to ask. And because you brought up Slurm, um, I wanted to dig a little bit more on that. So, in essence, when you start up one of your clusters, your Slurm nodes, particularly in the cloud, you're saying they don't exist yet until they get assigned a job. Is that
That's
pretty
right.
much how it
Yeah.
works? Oh, okay. So,
Running in the cloud is generally expensive, and people, if I were to compare a large on-prem system with doing that same type of thing in the cloud with, maybe best class networking, storage, and compute today, it could be, even be 5 times as expensive if you compare one to one. And this is part of
uh, yeah.
the cloud story where you don't actually need to compare one to one, and the total cost of ownership can become less if you right size your infrastructure. But yes, in the cloud, we provision Slurm clusters. AWS released their parallel cluster service last week. That's essentially what we're doing, and we've been doing that for years and years. And we do that on AWS in a very similar way, but we do it across all the different clouds we work in. It's a standard Slurm cluster. It looks as though a traditional Slurm scheduler, partitions everything. You get to determine the shape of the cluster, what type of login node you want, how many partitions you want, the regions and zones and instance types, the shapes that you want to use. And when you log into it, and we make it easy to log in over a terminal for conventional power user cluster users. It appears as a normal partitions. it just shows them idle, except the nodes aren't really there until you submit a job. When you submit a job, we scale them up. We go out to the cloud providers, APIs or SDKs, spin up the nodes. It takes about 3 to 4 minutes sometimes, depending on the cloud. It connects them into
Hmm.
Slurm, job runs. When the job finishes, they stick around for a little while and then we shut them down because we're incurring costs. Anything you touch, you're incurring costs.
Sure.
So we want to try to be economical where we can.
So just to, this is actually kind of an interest of mine because I've done some things with Slurm with turning systems off when they're not in use, physical systems. So are
Yeah.
you using that kind of mechanism built into
That
Slurm that
exact,
you can?
that exact, it's a power management plugin mechanism in Slurm.
Yeah, yeah,
Exactly the same thing. Yep. You
yeah.
got it.
That
It's really
yes.
just doing an intercept. It's doing an intercept at the resume level for the Slurm Power Management plugin. When it basically starts up, it's going to ask, here's the nodes I need. We go out and then hit any SDK, OpenStack, or any of the clouds. We go and get the node started up. Slurm D runs on the remote side, connects them in, and now it's showing them as idle without any other characters on it.
Right.
Runs the job and then shuts them down, and there's another intercept at that point. So it's not actually magic. It's just getting all of that kind of working reliably as the technologies evolve and change over time is a full-time job. We found,
Yeah,
and
I can
full team's
imagine.
job. Yeah.
Yeah. So just to kind of move back up a level here, I assume you mentioned this, you support all the major cloud vendors in this case. So it's just not an AWS product at this point.
Well, yeah. How do you define major cloud vendor? But yeah, that's right.
Well, ask the cloud vendor. They'll all tell you they're a major cloud vendor.
Right.
So yeah. Um,
So we support at the moment AWS, Google, Azure, uniform Slurm clusters on all of those. We are working on Kubernetes providers for all of those that would allow connection to existing Kubernetes clusters. I won't talk too much about that, at least now. We are working on an Oracle Slurm integration right now as well with the Oracle team. IBM Cloud is, again, depending on the community you go to, they're big in financial services. That's one we're
right.
starting to look at. And then for on-prem clouds, OpenStack is where we kind of went with that. So people that are operating on-prem bare metal resources as a cloud, we can integrate with OpenStack as the layer that does the virtualization. And we run Slurm on top of OpenStack then.
Got it. Okay. So we kind of answered my next question in a way. I said, so if I wanted to run a bunch of NAMD simulations and basically let's talk about in the cloud now. So I set up my system, submit my jobs to Slurm. It goes out, starts the nodes, runs the jobs. It's done, and then when I'm done, I assume it all collapses down to then a single node, as I understand it. So when the queue's empty, that's just your Slurm node basically,
Yeah, your
and that's all the
controller, it's like equivalent of a front end node stays around for the
right,
life of the cluster session. You can choose, you or administrators get to choose the cluster session time. They want to
right,
run it all the time or let the end users actually control them themselves. Yes.
right. Okay, got it. Yeah, that makes sense. I mean, it's a really economic way of
Yeah, I mean,
uh,
what we've seen following on that is like different organizations want their users to interact with these clusters in different ways. Our platform allows admins that are managing the computing environments to come in and create one or a few clusters and share them with an entire organization or specific project teams and operate them kind of like a traditional HPC, shared asset, right? Where lots of users are all sharing the same cluster. There's
right,
persistent storage attached to it, and it literally looks and feels like another site, another computing site. But it just so happens it's in Azure or it's in Google or whatever or AWS. What we've found that is kind of interesting is that if organizations put a policy in that gives more, let's say, ownership to the clusters, to the end users themselves, what we're seeing is the end users are empowered to come in and build their own clusters and choose the
Mm.
shapes of the things they want. And you know, they own them either as personal clusters and they can attach whatever their storage into it, or they share, the end users themselves are collaborating with a small project team or some project team, and it becomes like a collaboration environment for that. So that we've seen that happen pretty successfully. And then people start using these clusters, which it takes the idea of a normally large static shared cluster, and it turns it into these pretty agile computing systems that we have some groups, for example, they just published a press release from NOAA R&D on their hurricane forecast system. This team, it's about 20 people within NOAA R&D. They have 20 clusters, shared clusters in an account, and they run every individual ensemble member on a different cluster with its own dedicated Lustre file system. And
Nice.
and it's kind of interesting. And then they automate that with our REST API. Every 6 a.m. every morning, they start 20 of these standalone clusters that are shared across the entire team and send an ensemble member to each one. So it's been interesting to see how people have been using this idea of clusters, which are usually in a traditional HPC sense static things that are not changing and shared amongst a lot of users, to things that are now pretty lightweight and agile.
Yeah, so that actually brings me to my next question. Was when you start getting to the nitty gritty of defining and setting up a cluster, every cluster I've ever been involved with, they all look different from a hardware resource perspective. Some of them may have certain nodes with GPUs, some certain amounts of memory, etc. Different interconnects, anything from a slow old Ethernet connection to InfiniBand, numbers of cores, all that kind of stuff. And then the big one though is, you know, how do you bring in parallel file systems, if at all? So I know I've had years ago working with some people who just did everything over NFS and then would complain about why is this so slow,
Yeah,
which was explained to them. And so those issues, how do you encapsulate those issues? I guess is what I'd like to know.
it's fairly, you kind of definitely mentioned a lot of the challenge points. Storage and file systems are fundamental to every workload, and they are pretty workload specific. So it really depends on what you're trying to do. um, but so we've designed our platform to try to be flexible enough to allow a wide variety of storage tiers that the cloud providers use, or there's commercial solutions out there that are doing like global namespace actions and everything. So we try to make it so that the end users, again, could have the autonomy to define what they want to do themselves. And our team exists to provide best practices. If you're doing tightly coupled MPI jobs, we have kind of like an out of the box deployment that can do that. Take your highest performance, fastest, but most expensive file system, make it ephemeral, attach it to the cluster, stage your data in and out through object storage. We have like best practices to follow based on what you're trying to do. The bottom line is this technology we've been building, our software, makes it so that you can provision these things with some guardrails. We don't allow everything that you can do in like any of the cloud consoles directly, but the HPC and AI specific things like shared, medium to low performance, but of economical shared NFS mountable file system, Lustre file system for high performance, more specialized file systems that each cloud provider has, Azure NetApp files, Google's GFS, et cetera. You can actually provision these and then mix and match them on a cluster yourself or with your project team. And what we see is that when you make a cluster definition, or users make a cluster definition in our platform, they get to choose what storage is appropriate for their workflow and then just mount it along with it.
Got it.
Yeah.
Yeah. So this is I want to mention what I have found to be one of the thornier issues with cloud computing. And we're talking about cloud, and um, I've heard many stories floating around about the end of month cloud surprise when they get the bill, and usually costs exceed expectations and oftentimes budgets. So the reason often cited to this, when I talk to people about it, they said there's sometimes a disconnect between, you know, running the application and then knowing what's the cost on the, I call it the taxi meter. You know, you
Yep.
um, that is even running when you're not going anywhere. So um, and that's why they like it's not real clear sometimes, like what's this going to cost me, or is it costing me while it's running, so forth and so on. So
Right.
I recall hearing last week at the HPC and AI on Wall Street show, you talk about some capabilities of Activate to help about with this issue. So I'd like to
Yes.
hear a little bit more about them.
Yeah. First of all, I wish we didn't have to solve this problem. I wish that it I wish the cloud providers gave you the costs as they occur in real time, right? But it's, it's a complicated problem. You know, the cloud providers have sometimes thousands or tens of thousands of individual SKUs that are all accumulating to some taxi meter runtime as you're getting a job done. And also, it's perhaps not in their best interest to tell you exactly what you're spending right away. Now that is a direct conflict with many organizations' requirements to have fixed budgets for an annual cycle, right? It is very difficult to enforce true fixed budgets in a cloud environment, and the reason for that is because the cloud bills are delayed coming back. If I start a job right now on Azure, let's say, with my 10 nodes and my Lustre file system or whatever, and I think it costs $100 an hour, I actually won't know 12 to 24 hours later what the true cost of that job was. That's when they would publish the real bills to me. Uh, what started happening for our user base that's spinning up, 10,000 CPU cores or like a cluster of 20 to 30 GPUs or something, and they're spending a lot of money, the managers of the organization that say, hey, this project can only spend $10,000, they would blow past that budget before they even get the bills back from the cloud provider. And that became a problem. That started about 4 years ago when this was really becoming front and center on our customers that wanted to truly enforce fixed budgets with very tight control at direct conflict with the CSP cloud service provider billing models. So unfortunately, we had to build a FinOps capability specific for HPC and AI, these type of workloads that, and again, we're not a cloud service provider. We are not reselling cycles. We don't get involved in the consumptions. We're a piece of software that just orchestrates in other people's cloud accounts. So we actually had to build a module that looks into the cloud accounts that we're running in and tracks spend at a 3 minute, we do it at a 3 minute resolution. So every 3 minutes, we have a system that looks in your organization's cloud accounts or the views that we have access to, and we get a cost estimate. We call it a real-time cost estimate that we've dialed in to be about 5% accurate for all things except egress charges. Egress we found to be difficult to reverse engineer and quantify the spend on for some reason, and we've tried a lot of different ways. So within 3 minute resolution, we can get a roughly 5% picture of what the spend is at any given time. And we actually let the users see that in real time. They can go to an interface and see when their job is running, what their true cost spend is as it's running. And then the administrators are actually allowed to say, hey, enforce budget restrictions. If you're starting to meet a certain quota, we can actually shut down the resources based on that real-time estimate. So that has solved the problem of having these, and this has happened a lot, runaway jobs. Someone submits, 100 node job on a Friday night, and then they walk away, but it's just run away. We're able to actually get in front of that and shut things down before it becomes a really large expense. And we have some good case studies on doing just that.
Yeah, that's a big problem. I mean, you could have a separate company that does that.
Well, there is separate companies that exist just for FinOps purposes, for sure.
Yeah,
And we used to integrate with them, but then they didn't get us the resolution that we needed for HPC and AI jobs. You know, the large, we're doing bursty, large jobs generally, right? If someone comes in and spins up 1,000 cores or 5,000 or 10,000 cores, and they're doing maybe lots of those a day, you need a pretty fine resolution to do that. So
yeah.
I kind of wish we didn't have to build it, but we did.
So, one final question I wanted to throw out there is the and you've already made some what I believe some good arguments. But if you're given to give an elevator speech about how Activate saves money in a in a world where not everybody, but it was born out of a lot of DIY users who like to roll their own stuff.
It still is,
And
yeah.
yeah, and so it's not like, in a way, not like walking into a corporate environment saying, "Hey, we can automate X, Y, and Z." You're sometimes walking into an environment where you've got somebody who's been doing this their way for 20 years, and maybe it's you know works, but it doesn't provide a lot of what the organizations really need. So
That's our biggest competitor, really. It's exactly what you just said. It's people have been, and when we come into an organization, it does have to happen. We need to get end users buy-in, and that's really important, and make sure that their lives are going to become easier through using this. But the people managing these computing systems also need to buy in, right? And they need to say, we are really going to try this as a way for people to access our systems, which means it's a long cycle. Generally, it usually becomes part of like a refresh cycle when they're considering this. And like you said, a lot of people have built do-it-yourself solutions, or there is open source tools that do what we do. Open on Demand is one, for example. And to maintain these systems and then keep them up to date, especially as cloud has really emerged as a true competitor to HPC workloads. They work, their performance is there now. 5 years ago, we were starting to see that shift a bit, but it is there now. And there's obviously cost implications and OpEx implications, but it does work. And there's new clouds coming online with diverse technologies. There's a whole tier of GPU cloud providers that have the capacity that you need today, for GPUs when maybe the hyperscalers don't. So it's important to constantly be agile to these different environments, and then do-it-yourself solutions. They're out there. They work great, and so maybe environments that have kind of static single clusters or maybe a few clusters, or that world. But as soon as you move to like supporting multiple environments and all the difference between them, I mean, this is what we've been spending 10 years on, and we still haven't really fully cracked it, right? So, and you'll start running the do-it-yourself groups, start running into the same issues that we have been solving for years, in terms of even just operating a cloud program with fixed budgets, like I just said, right? Getting
right,
application portability between these different environments. And you may have an organization, and I've seen this a lot, that is an AWS shop today, and they're all in and they're fine with that. But Azure or Google just put some new technology on the floor that they want to use, or they're willing to give them a big discount coming up. How do you get portability between these sites? In a conventional do-it-yourself, we got to bring in an Azure expert who's going to know all the roles and permissions. What we're trying to say is, no, you don't. Use something like ours, and then your team is already the experts in these different clouds. We've already taken care of that. So that's kind of the story that we go into with that. And a lot of times they'll say, we're fine. And then they'll start running into these issues and come back, and like, hey, maybe we should really look at doing something like that.
yeah. Having grown up in this environment, I the what got us here were the roll your own rugged individualists that I've stepped into situations where, well, yeah, they're gone now, and we don't know how anything works. Is the other
No,
other
that's true.
issue in some organizations. So, Well, we're about the end of our time. Is there anything I forgot to ask or you wanted to mention in closing this up?
I think one last thing. We talked a lot about cloud today, but we do, our platform does operate fully on-prem systems as well, and it's used as a conventional portal interface in the old school term of the word.
Right.
Um, but what we've been seeing a lot of is that this hybrid multi-cloud world where, and this is kind of what we are feeling for all the reasons I said before. But when people have on-prem resources, organizations have on-prem resources, and they want to start introducing burst sites or even colo, but burst sites,
Right.
we are fully trying to accommodate those scenarios where it's like run a workload, use what you can on-prem first. If you can't get what you need in a certain amount of time, or if things are down or whatever it is, here's a fallback option that is already compatible with the workloads you're running. That's a lot of the workloads we're trying to run right now, or with customers. It's like they're not going to get rid of their systems. They got their annual refreshes; those are there to stay. It's about growing the small OpEx cloud budgets to help the burst scenarios. Really, that's where
Yeah,
we're trying
got
to
it.
really sit.
Yeah.
Mm-hmm.
So in as I understand it, so I can be managing my cluster on prem, and from a user standpoint, okay, we've got authorization that we can use burst to the cloud. So the finding more nodes to them is not really an issue. In other words, they can submit a job and then it can get sent to the
Yep.
cloud. And
Yeah, we do
what
that
you
at a
talked
workflow.
about
Exactly
spins
right.
up nodes as they need them and then brings them back down when it's done.
Yeah,
Do
and
I
you
have
may
that?
have a workload running every day that 80% of the time you can get your on-prem resources you need, but that other 20% of the time, this these pipelines just take care of sending it out to Azure or whatever cloud environment
Right.
you're running in. So that
Got it.
that's
Yeah.
exactly the case there. Yeah.
Yeah. All right. Well, this has all been very interesting, and at HPC Wire, we love to hear about the big systems and all that, but this is, in my opinion, a lot of the where the rubber meets the road with getting things done in HPC and in AI. So, thank you for contributing to this, and I'm sure we'll be hearing a lot more from Parallel Works in the future.
Yes, Doug, thanks so much. Really great to be here and appreciate the opportunity.